Good morning. I'll present our work on blockchain ecosystem for verifiable qualifications. My name is Miguel Correia, and this is joint work with my student Diogo Serranito, my colleagues André Vasconcelos and Sérgio Guerreiro. This is work being done in the context of project Qualichain, funded by the European Commission. So the organization of the presentation is this one, so I'll start with some motivation and an overview of the problem. Then I will present the ecosystem, which is the technical contribution of the paper, then the evaluation, and then some conclusions. Let me start with the motivation overview, and the motivation is a fact that today there is a major market of counterfeit or false, fake academic certificates or diplomas. And in fact, this is a complicated market. Okay, for instance, these are numbers from a recent study that show that 53% of the curriculum and job applications contain false information, and that 78% contain misleading information. Okay, so checking the authenticity of these certificates or these diplomas is a hard problem. Okay, of course, if they are delivered in paper, as classically happened, you can check the paper. Okay, you can check the stamp in the paper. If not, you can contact the university and check, is this true that this student really has a diploma in computer engineering, for instance? But how to do this in a globalized world? Okay, how to do this when you have submissions, job applications from different countries? Okay, for instance, you have students applying from somewhere else in the world. Okay. So we have this problem, okay, how to verify securely and efficiently certificate authenticity. So our work is a solution to this problem. So we propose a solution for the qualification verification problem, okay, and our solution is an ecosystem of consortiums of higher education institutions, or HAES. And our ecosystem is based on two smart contracts, okay, so one that basically manages the consortiums, and another one that stores authenticators of certificates of each HAE. Notice that we may have several of these consortiums. Okay, so we don't want to create a major consortium of all higher education institutions in the world. Okay, because this is not possible. We can have these consortiums locally. For instance, you can have an European consortium, then you can have an Asian consortium, for instance. Or you can have a China consortium, a US consortium, an European consortium, and so on. Okay? Inside these consortiums, you require some level of organization. So this is built on top of blockchain, okay? But the conference is on blockchain, so I'm not going to explain what blockchain is. This is built on top of Ethereum, okay? The conference is on blockchain and smart contracts, okay? So I'm not going to explain what is Ethereum. So I'll jump to the ecosystem, okay? So the ecosystem is represented in this picture on the left, okay? So here you see one consortium only, okay? And then can have several or even many of these, okay? So the consortium brings together a set of HAES. This set can be dynamic, okay? So you can have a set of universities in the beginning, for instance 10, and then add more with time. And this is managed by two smart contracts. Okay, so you have at the top the consortium smart contract, which is a smart contract that manages the membership of the consortium. So it allows HAES to join the consortium, to leave the consortium, and so on. Okay, it also allows something else, which is for the recruiters, the ones that want to check if a certain certificate is authentic, to obtain the address of the HAES smart contracts. Okay? So they can be aware only of the address of the consortium smart contract and not of the HAES smart contracts. Okay? So the HAES smart contracts are on the bottom, okay, and they belong to a HAE. Okay? For instance, my engineering school, Instituto Superior Técnico, we can have one of these smart contracts to store the certificates that we issue to our students. And so the ecosystem, as I already said, can contain several of these consortiums. Okay, this picture that is here on the left can be replicated many times, okay, by region, by continent, by some kind of organization. Then, of course, we have a set of clients that interact with this. Okay, so we have the Hey client, which is executed by a Hey that does registration and revocation of education certificates. Okay, so it puts the authenticators of certificates in the Hey smart contract. Then we have the recruiting app that is executed by recruiters to verify candidate certificates. And then we have the consortium app, which is not represented in the picture, and that interacts with the consortium smart contract at the top, that allows new Heys to join the platform through a consortium-based voting system that I will explain a bit later. So let me start with the consortium smart contract on the top of the picture. Okay, so I'll present briefly the main operations, or a subset of the operations. Okay, there are more. And by operations, of course, I mean the functions of the smart contract. Okay, the smart contracts were implemented for Ethereum in Solidity. Okay. So, of course, one of the main operations is register Hey that allows registering a Hey smart contract. Okay, so a new Hey, let's say Hey free, that is on the picture at the top on the right. It wants to join the consortium, so it registers there by calling this. Then we have remove Hey that allows deleting a Hey smart contract to cancel its registration in consortium. We have get Hey to return the smart contract, the address of the smart contract of the Hey, and we have vote register Hey that allows voting in favor of a Hey joining the consortium. But let's see this in more detail now. Okay, so sort of a use case. Okay, a new Hey wants to join the consortium. How is this done? So first, the new Hey simply deploys the Hey smart contract in the blockchain. Okay, so it installs this smart contract in Ethereum, and it gets an address for its own smart contract. Then the new Hey calls register Hey in the consortium smart contract at the top. Then the members of the consortium call vote register Hey to support the join or not. Okay, if they don't want that Hey to join for some reason, they don't vote. The registration of the Hey takes effect when, and of course if, the votes of the other members of the consortium reach a certain threshold. For instance, if the consortium has in the beginning 3 Heys, as shown in the figure, a 4th Hey wants to join, it does this process, okay, and then if it has, for instance, 2 votes, if the threshold is, for instance, half plus 1 or 2/3, then the new Hey can join. There are 2 similar schemes to remove a Hey from the consortium, okay, but instead of calling register Hey and vote register Hey, we have remove Hey and vote remove Hey. And to change the threshold, of course, the threshold is configured itself. Okay, so we can define that we need consensus for someone to join or leave, that we need majority, and so on. Then the Hey smart contract at the bottom. The main operations. So we have register certificate to register the certificate on the blockchain, to register a student certificate on the blockchain by storing its authenticator. Okay, so the code that allows authenticating if the certificate is valid. Okay, if it's authentic, and of course this is just a cryptographic hash of the PDF, for instance, of the certificate. Notice that the certificate itself is not stored in the blockchain. It can be stored somewhere else. It can be just a PDF that is sent by email or so on, or it can be stored in IPFS or something of the kind. Revoke certificate allows revoking a certificate. This is a quite uncommon operation because, of course, universities, Heys, what they do is to issue certificates. But in some case, there may be an error. Okay, for instance, there was some wrong information in the certificate. For instance, there was a misspelling of the name of the student. And there is verified certificate that verifies if a specific certificate has been registered and not revoked. So then entering the clients, okay? So a HEI, a university, executes the HEI client, okay? The picture is a bit confusing, okay? But here in the middle, okay, pointed by the arrow, we have the HEI client, and on the left, we have the academic management system. Okay? There are several systems of this kind, okay? We are considering specifically, well, probably one of the most, or the best known is Moodle, okay? We are considering one that was designed in our school, but many, many years ago, okay? It's open source, today is used by many universities. It's called Phoenix Edu. And so what happens is that a person in the university clicks on a button saying, issue the certificate for this student. The certificate is issued in the academic management system, and it's sent to the HEI client that puts it in an Ethereum node by calling register certificate in the HEI smart contract. Okay, so it basically calls this function in the smart contract. Okay. So this interface is pretty critical. Okay, so pretty critical is not the right word. Okay, it may be complicated, may require changing the academic management system. We didn't do that. Okay, so the HEI client simply monitors a certain folder, and what the academic management system has to do is to save, for instance, the PDF of the diploma or the certificate in a folder. The HEI client, when it sees that the folder there is a new file, it simply puts it in the blockchain. Okay, the recruiting app. Okay, so a recruiter, for instance, a public administration institution, a company wants to contract someone, or a university wants to accept a student that is applying for a country far away in the world. Okay, what it does, it interacts with the smart contracts. Okay, so it calls the consortium smart contract to get the address of the smart contract of the HEI. For instance, it says, well, the certificate is from Instituto Superior Técnico. So let me call the consortium smart contract to get the address of its smart contract. It gets the address, and then it calls the HEI, sorry, this is a mistake, this is HEI smart contract, to verify if the certificate is true, is valid, is authentic or not. Okay, and it gets the response. The consortium app basically does the management of the consortium, okay, registering new HEIs, removing HEIs, changing the threshold by vote. Okay, that's what is represented here. It has an interface for doing it. Okay, so it has a user interface that provides free forms to fill in with the comments, okay, and a list of ongoing polls, one for each of the contract main voting operation. Okay, so the list of ongoing votings. So, for instance, there may be several HEIs applying to register. There may be HEIs that want to leave, and so on. So the interface, and specifically, this is the app, a screenshot of the app for the operation register HEI, okay, as in here. Basically, you have to insert the identifier of the HEI and smart contract address, okay, and here you see that there is some pending registration for one HEI that you can vote in favor or against. So the evaluation. So we did a simple evaluation of the scheme, okay, so something not very complicated, okay, so we obtained performance metrics, throughput, latency, and cost. How much does it cost to execute this in Ethereum? So the scenario was we executed the smart contracts in the Ropsten testnet, okay, not in the real Ethereum, okay, because we didn't want to pay. All the operations that were evaluated were repeated 100 times at least. And we had certificates of approximately 100 kilobytes. and the cost was obtained in Etherscan, basically. So this table shows several of these numbers. Okay, it shows for free operations, hash certificate, revoke certificate, and verify certificate. Okay, the first and the last are more interesting, of course. It shows the throughput. Okay, this was the throughput, so the number of operations per second obtained on average with a single client. Okay, so of course we could have many clients, but at some point we would not be testing the throughput of our system. We would be testing the throughput or the ability of Ropsten to answer to requests. Okay, so something that is less interesting for us. Okay, so this is the cost. So the cost of verifying the certificate here is 0 because we did this verification locally, okay, in the local node, without actually waiting for all the, without actually executing the function, okay. So we're executing the function, we have a cost similar to this, and the latency, the same thing, okay. This one's really executed the function, okay. So the latency is greater than 20 seconds, because of course this is really executing something on Ropsten. Then you have to issue a request, you have to wait for the transaction to be placed in a block, for the block to be put in the blockchain, okay, and this takes time. We also have measurements of latency depending on the file size, okay, by varying the file size a bit, okay. So basically we see that the time increases slightly, okay, not much, because this is essentially the time to calculate the hash. We see that it oscillates a lot, okay, as expected, because we are contacting a blockchain that has a latency that is really huge for computer time, right, around 20 seconds. So, conclusions. So, we presented the first ecosystem for certificate verification at a large, potentially worldwide scale. This is an ecosystem composed of several consortiums. Each consortium is managed by a smart contract. Decisions are taken by votings of the members of the consortium. Another smart contract store authenticators of certificates at each hay. This is based on a permissionless blockchain, currently Ethereum, or a compatible blockchain. For instance, Ropsten is a compatible blockchain, although not a blockchain that is not supposed to be used in production. So thank you very much for your attention, and I'm ready to take questions.